If a straight line be cut into equal and unequal segments, the squares on the unequal segments of the whole are double of the square on the half and of the square on the straight line between the points of section. So starting with line AB, we bisect it at C, and then we cut it at random at D. What we are trying to prove is that AD squared plus DB squared are equal to 2 times AC squared plus CD squared. Let's perform the construction first. We draw CE perpendicular to AB such that CE is equal to AC. We will then join EA and EB, and then we will draw DF perpendicular to AB, so parallel to CE. It will meet EB at F, and then we will join AF, and then we will draw GF parallel to AB, such that G meets at CE. The strategy we're going to use to prove this proposition is first, we will draw some conclusions about the angles and what lines are equal to others, and then we will use the Pythagorean theorem to show how the squares of these lines relate to each other, and then arrive at the conclusion that we wish to prove. First, AC is equal to CE, so we have an isosceles triangle. Therefore, angle EAC is equal to angle AEC. Now, notice that angle C is a right angle. Therefore, the other two angles of this triangle are equal to a right angle. And since these two angles are equal, we know that angle EAC is half of a right angle. And angle AEC will also be half of a right angle. Similarly, angle CEB and angle EBC are equal to half of a right angle. Now we know that angle EGF is a right angle, because GF is perpendicular to EC, it being parallel to CB, and we know that angle GEF is half of a right angle, therefore angle EFG is half of a right angle as well. These two angles being equal, we know that triangle EGF is an isosceles triangle, and therefore side EG is equal to GF. Now angle FDB is a right angle. Angle FBD is half of a right angle, therefore angle DFB is half of a right angle. And again, we've got an isosceles triangle with triangle FDB, and therefore FD is equal to DB. We are now ready to apply the Pythagorean theorem to what we have. AC is equal to CE, therefore the square on AC is equal to the square on CE. By the Pythagorean theorem, EA squared is equal to AC squared plus CE squared, which we just showed was 2 times AC squared. Also, looking at triangle EGF, by the Pythagorean theorem, EF squared is equal to EG squared plus GF squared. GF being equal to EG, we thus have that EF squared is equal to 2 times GF squared. GF is equal to CD, so EF squared is equal to 2 CD squared. So we have these two relations. If we add them together, we have that EA squared plus EF squared is equal to 2 times AC squared plus CD squared. So notice triangle AEF. We know angle AEF is a right angle because angle AEC and angle CEF are half of right angles. Therefore, by the Pythagorean theorem, AF squared is equal to AE squared plus EF squared. So AF squared is also going to be equal to 2 times AC squared plus CD squared. Now, notice triangle AFD. Angle FDA is a right angle, so, again by the Pythagorean theorem, AF squared will also be equal to AD squared plus FD squared. But FD is equal to DB, so AF squared is also equal to AD squared plus DB squared. Therefore, we have our result that AD squared plus DB squared is equal to twice AC squared plus CD squared.